Hello everyone, this is Ajay B, studying in Sri Venkateswara College of Engineering in the Department of Computer Science and Artificial Intelligence. The topic is about software engineering and the practices done for software engineering. Software engineering is the application of engineering principles to the design and development of software systems. It involves a systematic and disciplined approach to software development encompassing planning, analysis, design, implementation, testing, deployment, and maintenance. The software development lifecycle. Now we'll be knowing about the phases, methodologies, and teamwork in the software development lifecycle. Coming to the phases, the software development lifecycle, that is SDLC, is a structured approach to software development. It involves a series of phases that guide the process from initial concept to development and maintenance. Whereas methodologies, there are various SDLCs methodologies like waterfall method, agile method, and scrum method, each offering different approaches and strengths. The teamwork is effective requires collaboration among software engineers, designers, testers, project managers to ensure successful outcolor. Now we'll also know some requirements gathering and analysis by step by step. The first step of the software development lifecycle is requirements gathering and analysis is very crucial for the success of any software project. The first step is identify needs. Understanding the purpose and goals of the software is required. The second step, user stories, capturing user perspective and desired functionalities. Functional specs, defining specific features and how the software should behave. The non-functional specs, addressing performance, security, and usability requirements. Through detailed analysis and through documentation, the software engineering team can ensure that the project meets the needs of its stakeholders. Design and architecture. The software design defines the blueprint of the software system, outlining its structure, components, and interactions, which follows as below. The system architecture specifies the overall structure and organization of the software. Data model, which defines the structure and relationships of data used by the system. User interface design focuses on the visual presentation and user interaction. The component design. This component design details the design of individual software components. The software architecture determines how these components are arranged and how they interact, ensuring a robust and maintainable system. Coming to the implementation and coding, choosing the right language. Selecting the appropriate programming language is very crucial and as important considering factors like project requirements and team expertise and available libraries. Writing a clean and efficient code. The maintainability and readability are essential for long-term success. Employ coding standards and modular design and well-documented code. Utilizing development tools. The modern IDEs, version control systems, and debugging the tools enhance productivity, collaboration, and code quality. Testing duration implementation. Unit testing and integration testing are crucial throughout the implementation process to ensure code functionality and prevent errors. Testing and quality assurance. Unit testing, the individual components are tested to verify the function as expected. This isolates errors and which makes debugging easier. Integration testing. The different parts of the software are combined and tested together to ensure seamlessly interactions. System testing. Here the entire system is tested to ensure it meets the overall requirements and specifications. User acceptance testing. End users evaluate the system's functionality and usability to ensure it meets their needs. Performance testing. The tests of systems responsiveness and stability and scalability under different loads and conditions. Security testing. This identifies vulnerabilities and weaknesses in the system to protect sensitive information and ensure secure operation. Deployment and release. The build and package. The software is compiled, packaged, and prepared for deployment. This may involve creating installation files or containers images. Environment setup. The target environment is configured and prepared. This includes the setting up servers and databases and other necessary components. Deployment process. The software is deployed to the target environment, which can involve transferring files, installing software, and configuring settings. Testing and validation. The deployed software is tested to ensure that it works correctly and meets all requirements in the live environment. Releasing and monitoring. The software is officially released to users and ongoing monitoring is implemented to track performance and identify issues and ensure stability. Maintenance and support. First one is bug fixes. This addresses the reported issues in the program while compiling. Performance tuning. This optimized for efficiency, security updates, patch and vulnerabilities, feature enhancements. This adds new functionalities to the programming language. Maintenance and support are crucial for ensuring the longevity and success of software product. It involves addressing bugs, improving the performance, enhancing security, and adding new features to meet evolving user needs. A dedicated team ensures the software remains stable, reliable, and user friendly over time. Software engineering principles. Software engineering principles include modularity, abstraction, encapsulation, information hiding. The modularity. This is breaking down complex systems into smaller and manageable components, improving code and reusability and maintainability. Whereas abstraction, with simplifying complex systems by hiding unnecessary details, focusing on essential aspects, and reducing cognitive load. Encapsulation is bundling data and methods within objects, protecting internal data and external interference, promoting data integrity. Information hiding, concealing implementation details, promoting code reusability, and minimizing the impact of changes on the other parts of the system. Coming to the conclusion, we'll know about the trends and future of software engineering. Software engineering is constantly evolving with new technologies, methodologies, and trends emerge regularly. The future holds exciting opportunities with artificial intelligence and machine learning play a pivotal role in shaping the future. Cloud computing continues to gain momentum. Software development is moving towards a more collaborative and agile approach.